In this video, we're going to take a look at how you solve absolute value inequalities. Now, if you're not real familiar with or comfortable with compound inequalities, you may want to take a look at the video on solving compound inequalities before you do this, because all absolute value inequalities are going to turn into compound inequalities as we solve them. But assuming you're comfortable with that, we're going to move on and take a look at the kind of problem that you may encounter here. Here is an absolute value inequality recognized by the absolute value signs as well as the inequality sign, the greater than sign in this case. And we want to solve this for the missing x. Now, just like with equations, the first thing you always need to do is isolate the absolute value sign or the absolute value part of the equation so that it's by itself on one side. In this case, it already is, so we don't have a lot to do with that. And then you have to look at the inequality sign itself. It's greater than. Greater thans need to be rewritten as compound inequalities with or. And here's how you do it. You rewrite the inequality exactly as it appears without an absolute value sign for one side. You put the word or in, and then we write it again with the part that's in the absolute value signs written the same, but we flip the inequality sign over. If there were an equal included, we'd include it here, and we change the sign of everything that's on the right hand side. And we solve these two linear inequalities separately. So in this case, we go back over here, we would subtract 2 from both sides, so 3 minus 2 leaves 1, divide by 2. So the first part of our inequality is that x is a number greater than 1/2. Second part over here, we subtract 2 from both sides, so 2x is now less than -5. Divide both sides by 2. And x is less than -5/2. I actually like to write that with the small one on the left. So I say x is less than -5/2. The word or is part of the solution, or x is greater than 1/2. Realizing that any number that is less than -5/2 works, or remember or means either any number that's greater than 1/2. So any number you pick in either of those works. Sometimes it helps to look at a number line, and we'll just draw a simple one here. If 0 is right there, then -5/2 would fall somewhere about here, and we'd draw an open circle, not a very good one. We draw an open circle at -5/2 to indicate that it doesn't include -5/2, and then it would shade everything to the left of that. So that open circle is at -5/2. Also, we'd go here to the right and draw another open circle indicating equal is not there, and it would be everything to the right of that we would shade. So as you can see, it goes to infinity that way. Any number that's not between -5/2 and +1/2 is going to be included in our solution. So most numbers are. So this is our solution to the inequality absolute value of 2x plus 2 is greater than 3. Let's look at another one here. This time we have less than. Less thans become ands for compound inequalities. Actually, I think a little bit easier to write, but we first need to isolate. Notice how there's a -8 in the way here. So we need to get rid of the -8 on the side where absolute value is by simply moving it to the other side and adding it to 3. So now we have 11. So 3 plus 8. And now we can write our and inequality. This is a bit easier to do. We rewrite the absolute value part, -3x plus 2, without absolute value signs. And then on the left side, we put a less than sign, and we put the negative of whatever is over here. So this time it's -11. another less than sign after it, and then whatever is on the right side, in this case positive 11. So we basically are rewriting the equation here, and then on the left side of that we're adding the negative version of the right side of this equation. And now we just solved this compound inequality by subtracting 2 from the middle, which means we're going to subtract 2 in both of these places. We get negative 13. Those cancel. Negative 3, x, and 11 minus 2 is 9. And to get x by itself, divide by negative 3 in all three places. And one thing we have to remember is when we divide by negative 3 or any negative number, we have to flip over the inequality sign. It becomes greater. Same thing happened over here. We divided by a negative, so we have to flip the inequality. And again, I probably would prefer to write this by saying negative 3 less than x less than 13/3. In red, x is between negative 3 and positive 13/3. So there's my final answer for the inequality. Absolute value of negative 3x plus 2 minus 8 is less than 3. One more problem. This is another greater than. Notice this time it has the equal included. So again, this is a problem that involves or. So we need to separate this. It's already isolated. Separate it into negative 4x minus 8 is greater than 16. Rewriting that one. Or negative 4x minus 8, flip it over, is less than negative 16. And solve each inequality. So I'm going to add 8 to 16 over here, getting 24, divide by negative 4. Remember, there I am again dividing by a negative number, therefore I flip this inequality sign. It becomes negative 6. X is less than or equal to negative 6 on this side. And then over here, I'm going to add 8 to negative 16, meaning I get negative 8, divide by negative 4, and x is also equal to, divided by a negative number, so I need to flip this over, greater than or equal to positive 2. And again, if I rewrite this, the final solution, x is less than negative 6, less than or equal to, or x is greater than or equal to 2. So that's some examples of how you can solve an absolute value inequality by changing them into the appropriate compound inequality. Remember, if it's greater than or equal to, it becomes an or problem where you separate it into two equations. One is just like the original inequality without the absolute value. The other, the absolute value part is the same, but we flip the inequality sign and change everything on the other side to the opposite sign, positives to negative, negatives to positives. Solve each individually, put them together with an or to get your final answer as we did on this one. If it's a less than, that's an and compound inequality, which means you put what's in the absolute value signs between the negative and positive versions of whatever's on the right side. If you'd like more help with problems that involve absolute values or compound inequalities or many other topics, I invite you to go to my website at MyMathEducation.com or subscribe to my YouTube channel, MyMathEducation, also on Twitter and Google+. Thanks for watching this video. Hope you'll come back to watch some more.